Okay, this is number one in your book, and the goal is to find the inverse Laplace transform, right, f of t, and then we want to sketch our graph, and our graph is going to be a piecewise function, and it's going to involve the unit step function. Okay, so let's just go ahead and start. So we want to find the inverse Laplace transform. So I'm just going to go ahead and write, the Laplace inverse or inverse transform of our f of s. And then, well, what is our f of s? It's given. That's e to the negative 3s over s squared. Now I'm just going to go ahead and rewrite. This is number one, so it's not too involved. But I'm just going to go ahead and write this as e to the negative 3s times 1 over s squared, because hopefully this helps you use the theorem in your book. And the one I'm going to use is Theorem 1 on page 305, and I'm just going to go ahead and write it. So from Theorem 1, well, I want to definitely find the Laplace inverse. So that is... Yikes, that is thunder. Oh my gosh, sorry if you guys can hear that. Oh my gosh. Okay, capital F of S equals U of t minus A, F of t minus A. Oh, my heart's racing. Sorry about that. I'm from California, so I hardly hear these guys. Okay, so we were at, okay, so this is a theorem in the book, and this is what I have, right? I have a e to the negative 3s, right? It's right here, and then this is my f of s. So let's just circle, right? This guy is my e to the negative as, right? Where in this case, a is 3, right? Because it's e to the negative as, so a is 3. And 1 over s, right? This guy is our capital f of s, right? And it looks exactly like this. So I'm allowed to use this theorem, right? It's basically a translation on the t-axis, which I will graph later. It's basically just a horizontal shift. Okay, so let's rewrite this. So let me maybe continue here. So equals, well, it's u of t minus a, right, where u is our unit step function. And sometimes you might hear it, or you might have heard it as the Heaviside function, and sometimes it's called h of t minus a. If you haven't heard about it, that's fine, but it's really the same thing. Okay, so we have u of t minus, and my a is 3. And then I have f of t minus 3. Okay, so this is again from Theorem 1 in your book. And again, this is a nice, right? We have a function, right, of t. And again, this is from algebra. This is just a translation, right? Oops. This is... well, let me maybe just explain or write this out. Okay, this is really the function, I mean, f of t equals t, right? It's the identity function, right? It's just shifted 3 units to the right. All right, sometimes we call it the parent function. I mean, it's a linear function. I could do anything to a linear function. In this case, we're translating it 3 units to the right. And this guy is our unit step function. And our unit step function, right, well, in the previous video, I think the instructor did just a great job explaining that. Okay, so let's go ahead and I mean, that's basically our Laplace inverse transform, right? That's our f of t. So let me just go ahead and write that out. So that's our function, but what does this mean? Okay, well, again, this is a piecewise function. So okay, so I'm going to write f of t. Okay, so I'm describing, right, this, well, this whole guy, right, that I just kind of boxed here. And it's going to be, well, we're definitely going to have a 0 because remember, we're turning, we have an off and an on switch. So it's going to be off, right, this system at 0, and then it's going to turn on, right? I mean, we call it a unit step function because it comes from 1. It starts at 1. But in this specific case, it's going to be t minus 3. And here t is going to be strictly less than 3. But when you get to 3, so when t is equal to 3 or greater, we're going to have this function. So again, this is just a quick sketch. So there's our f of t, right, and our t-axis. And then, of course, it's a function of t, right, or time domain. And again, this is, you don't really need a calculator for this one. This is a pretty easy function. So let's see, at 0, it's going to be, right, so let me maybe write 3. So it's off, right, at 1, 2, right, maybe 3 seconds, 3 hours. And then it starts, it jumps, right, it skips to, whoops, right, it jumps to t minus 3. If it was 3, right, it would be another constant function at 3. But t minus 3, well, that's just a linear function, right? At your slope is 1, your y-intercept is -3. Let's see, I want to draw this correctly here. So we have, right, 1, 2, 3, right? Pretend these guys are equidistant. So that's -3, right? That's really your y-intercept. And if you go up 1 over 1, right, up 1 over 1, up 1 over 1, I mean, this is that's the function t minus 3, right, or f of t equals t minus 3 when t is at least 3. But remember, this is a piece, this function exists when t is strictly greater than 3, so we don't need this piece. But I did want to draw it in because, I mean, that's what the function is. But we can definitely ignore this piece. And let's see, maybe I'll draw this guy in blue. So this is really, I'll make that a little bit thicker. So that's supposed to be a nice straight line. So that's my piecewise function, the pink and the blue. So hopefully that makes sense.